Welcome to ICOM's video training for auto-timed GPS send. In this training, we will show you how this function works, and how to set it up. Let's see how the auto-timed GPS send works, in a time flow, when configured as shown here. Time marker is 10 minutes and 0 seconds, interval timer is 20 seconds. Assume that the radio is turned on, at 10:09 and 48 seconds. The radio waits for 1 minute, until the first GPS data TX, expecting the GPS to be fixed within this period. Assume that the GPS is fixed, within 1 minute, as expected. 1 minute after being turned on, the radio transmits GPS data. At the same time, the radio sets the last time of day, ending with the minutes and seconds configured in here, as the time marker this time. So in this case, it's 10:10 and 0 seconds. And calculates the TX timing, allocated for itself, according to the interval timer and the time marker. The radio continues sending the GPS data, at every allocated time. But what if the GPS was not fixed before the first GPS data TX, in other words, within 1 minute after being turned on? Let's see next. Although the GPS has not been fixed yet, GPS data is sent out as invalid, 1 minute after being turned on anyway. The radio keeps sending invalid GPS data, every period configured as the interval timer, but possibly at the unintended timing, until the GPS is fixed. Assume that the GPS is fixed, at this moment. Now the radio can set the time marker to 10:10 and 0 seconds, in the same way as before, then calculates the TX timing allocated for itself, according to the interval timer and the time marker. Now the radio starts sending valid GPS data, at every allocated time properly. As demonstrated so far, the time of day of the time marker can differ depending on what time the radio is turned on. In this case, the time marker for radio 1 is 10:10 and 0 seconds. If it was turned on earlier, like at 10:08 and 48 seconds, the time marker for radio 1 would be set on 9:10 and 0 seconds. However, the timing of the GPS data TX should be constantly at the intended time of day, no matter when the radio was turned on, as shown next. In this case, the radio sends GPS data at 10:12 sharp, even the time marker changes depending on the time the radio was turned on. To ensure this setup, the value of interval timer in seconds should be a divisor of 3600, like these. On the other hand, if the interval timer is not a divisor of 3600, like 21 seconds, the radio either sends or doesn't send GPS data, for example on 10:12 and 6 seconds, depending on the time the radio was turned on. This is normally not a good thing, should be avoided. Next, let's imagine collecting GPS data from a number of radios. The time gap between each radio needs to be determined first. Let's say 5 seconds for example. Set some time point and time marker for the first radio. Not so deep consideration is needed, as this is just a reference point. Leaving the default value, 10 minutes and 0 seconds should be fine for the first radio. For the other radios, set the time marker, having 5 seconds gap between them, like this. The interval timer should be calculated as multiply the gap time by the number of radios. This is the minimum interval, not to be overwrapped. In this case 5 by 5 equals 25 seconds. Then set the value of 25 seconds, in all radios, but don't forget that the interval timer should be a divisor of 3600. For example, if you have 70 radios, then 70 times 5 seconds is 350 seconds, but this is not a divisor of 3600. So in such a case, The interval timer should be 360 seconds, that is a divisor of 3600, larger than 350. Lastly, you may need to have more frequent location updates. This is configurable like this, but the shorter gap for the frequent updates will result in shorter battery life, higher risk of data loss caused by collision, even though the timing is based on the GPS time, and also the more workload for the receiver side. So, a well-balanced configuration considered from various aspects, and a thorough pre-test in the actual system, are required to be ready for the real operation. Let's summarize today's training. The first GPS data is sent out 1 minute after being turned on, regardless of GPS acquisition. The interval timer value in seconds should be a divisor of 3600. Keep the balance of cons and pros of shorter gap time,